In this video, I will explain you how wave theory can be applied in the case of refraction. In the case of refraction, we know that sin I by sin R is equal to N2 divided by N1. Okay. So we will try to get the same relation with the help of wave theory. Now as per wave theory, wavefront is being propagated in one media. So this is medium 1, and in this medium 1, velocity of light is light is equal to V1. Let's say in this medium, this is also a transparent medium, but velocity of light here in this medium is equal to 2. So this is velocity V, vector V and vector V. This is V1 and V2. Okay, now wavefront is from a source, wavefront is generated and these are propagated through this media, and these are the wavefront and these are plane wavefront. Okay, now on the wavefront reaching at this point, this cannot send wavefront, this can send wavefront in forward direction, but the thing is this cannot send with the same speed, because in two different media we will have two different value of velocity of light, right? So here if the velocity is V1 and let's say this is air, this is a rarer medium and this is denser medium, for example glass. So in glass the velocity of light won't be same as that of velocity of air, and I could say that in glass, as it is denser medium, velocity of light would be less than velocity of air. Now from here wavefront, wavelets would be generated because this will act as a secondary source of light and wavefront is being generated in this direction. So what will happen, see here you can see that this wavefront in a time t it can reach this position, but at the same time in this case this wavefront cannot reach this much position, the same distance. Why? Because here the velocity is a higher value, here the velocity is a lower value. I will explain it once again. Now let's say I have a car which is moving at a velocity of 10 meters per second, and I have different car which is moving at a velocity of 20 meters per second. Now after 2 seconds, where would be these two cars? After 2 seconds this will cover 2 into 10, 20 meters, and this would cover 2 into 20, 40 meters. Now here, if this wavefront travel this much distance, then with the same time, this could only travel this much distance. Now from this point, I have to draw a tangent to both the wavefront. Now this wavefront, this point will also act as a secondary source of light, and this will send wavefront in this direction, in this direction, in this direction. This will send in this direction, so next wavefront. This will send in this direction, this will send in this direction, next wavefront. This in this direction, next wavefront. Okay, so this is the process of refraction. Now have you got the reason why the light ray has bent? The reason is the light is having different velocity in different medium. Now if this velocity in this medium, if it is high, what will happen? So these two are incident ray. Now see, by the time this travel a distance of this, my incident ray would travel a higher distance. Okay, so this distance is, if it is 2 centimeter, this distance is around 5 centimeter, because this is a rarer medium. Now what will happen in this case? In this case, this is the next wavefront, tangent to these 2 points, and this will send new wavefront in this direction, this will also send in this direction. So this would be the next wavefront. This would be the next wavefront. One wavefront, another wavefront. So if I am drawing with respect to this, it will looks like this. So what has happened here? A ray has came and it has bent in this direction. See, a ray has came and that has bent in this direction, because this is denser here and this one is rarer. Okay, now the thing is, as the light is traveling with different velocity in different medium, the process of refraction is occurring, or process of bending the light when it travels from one medium to another medium is happening. Now we will see whether this equation hold true. So I have an incident ray. Okay, this is the wavefront. This wavefront has created a wavelet here. At the same time, this has created a wavelet here. Okay, now this light ray has bent here. Now this will create a wavelet here, and this is how the wave would be propagated. This is bent towards it. Now anyway, by the time this wavefront, so this will be creating a wavefront at here. By the same time, the other part of the wavefront, so the whole thing is one wavefront. So this is creating a wavelet here, and at the same time this would create a wavelet here. Okay, so this two I have to join. These two I have to join. Now in the next point, this will create a wavefront here, this will create a wavefront here, and this I have to join to get the tangent. Anyway, by the time this reaches here, this will reach here, but I could say that this will be V1t and this would be V2t, because here this is the velocity of light and this is the velocity of light in this medium. Now in this example, the V2t would be less than V1t, so I have to draw in this way. Okay, here this distance should be less than this. Why? I have taken the example of light entering from rarer media to denser media. So this is rarer media, denser media. In rarer media, light has higher velocity, so it will travel more distance in the same time that the light travels in denser media. Okay, now this is the angle of incidence in between the incident wavefront and the surface of refraction. Now here in between the refracted wavefront, this is the refracted wavefront. After refraction, this would be the wavefront, next wavefront, next wavefront. So in between this and the plane, I have angle of refraction. So this can be defined in two ways. One is in between the ray and the normal I, or in between the refracted ray and normal R, in between the normal and the refracted ray R. Both are the same. I have explained in the previous lecture. Now from here, what is sin I? Sin I is equal to opposite V1t divided by hypotenuse. This is 90 degree, this is 90 degree, because ray makes 90 degree with wavefront. Ray makes 90 degree with wavefront. V1t divided by hypotenuse. Let's say AC is hypotenuse, so V1t divided by AC. Now what is sin R? Sin R is equal to opposite. What is this length? V2t. V2t divided by hypotenuse AC. Now sin I by sin R, AC would cancel. This will become sin I by sin R is equal to V1t divided by V2t. T will cancel and V1 by V2. This is a constant, right? How this will become a constant? Velocity of light in this medium will always be a constant. In this medium will always be a constant. So sin A by sin R is equal to V1 by V2. So this can also be written as V1 by V2 is C by V2 divided by C by V1. C is the velocity of light in vacuum. So C will cancel, V1 will come to the top and this will become V1 by V2. But why I have done in this way? Because I know C by V2 is equal to refractive index of second media divided by C by V1 is refractive index of first media. So this can also be written as N21. But anyway, this has been proven. Sin I by sin R is equal to N2 divided by N1. This is as per the laws of refraction, okay, which is N21, N2 divided by N1. So the moment we prove that the sine of angle of incidence is equal to sine of angle of incident divided by sine of angle of refraction is equal to a constant, the laws of refraction is proven, and the constant is N2 divided by N1, and that is nothing but refractive index of second media divided by first media. In this case, second media is a denser media, first media is rarer media. Now this hold true in vice versa, that is entering from a denser media to rarer media. But when entering from denser to rarer, the incident ray would move away from the normal. In the case of rarer to denser, the incident ray will move closer to the normal. That is the only difference. Okay, thank you.